Okay, we're here to try some more examples of the addition and subtraction formulas. So this time we're going to use the formula for cosine of a minus b and the cofunction identities to derive the other three addition and subtraction formulas. If you remember, back in the previous set of examples, we proved the formula for cosine of a minus b, and we did it without using the other addition and subtraction formulas. So we aren't getting trapped in any circular loops of logic. We really did prove the cosine of a minus b formula from scratch. But now that we've got that available to us, we're going to start with that formula, and we're going to try to derive all the others, and hopefully it'll be easier than the original proof of the cosine of a minus b formula. So let's remember what that formula is, because we are allowed to use it now. The cosine of a minus b is equal to cosine A cosine B plus sine A sine B. So we're allowed to use that, and we want to derive the other three formulas. So I'm going to start with cosine of A plus B, and I'm going to write that as cosine of A minus negative B. So I'm going to write an addition in terms of a subtraction. And the point of that is that now I can use my subtraction formula. So this is cosine of A. I'm just going to invoke this formula above, except wherever I see a B, I'll change it to negative B. So I have cosine A, cosine of negative B now, plus sine of A sine of negative b. And now remember, cosine is an even function. That means cosine of negative x is just the same as cosine of x. Sine is an odd function. Sine of negative x is equal to negative sine x. Sine is an odd function. So I've got cosine A and cosine of negative b, but cosine of negative b is the same as cosine b. Now sine A and sine of negative b, sine is odd, so sine of negative b is negative sine b. But look now, I've got cosine of A plus b is equal to cosine A cosine b minus sine A sine b. That's the formula for cosine of A plus b. So I was able to do that much more quickly than we were able to prove the original formula for cosine of A minus b. So let's see how that works for sine of A plus b. And now I'm going to have to bring in the cofunction identities. So let me remind you what those are. Those say that cosine of pi over 2 minus x is the same as sine x. And sine of pi over 2 minus x is equal to cosine x. So somehow we're going to use those to derive the sine formulas from the cosine formulas. So the way we do that is I have sine of a plus b, and we're going to use the first cofunction identity and write that as cosine of pi over 2 minus a plus b. That's by the first cofunction identity. Now that's cosine of pi over 2 minus a. I'm going to group those two terms together, and then minus b, because it was minus the quantity of a plus b. And now I'm going to use my cosine formula, my cosine subtraction formula, this one that we started with. So cosine, I'm going to substitute in, instead of a minus b, I have pi minus 2 minus a minus b. So this is cosine of the first term, cosine of pi over 2 minus a. Cosine of the second term is b, plus sine of the first term times sine of the second term. But now, cosine of pi over 2 minus a, again using the cofunction identity, is just sine of A. Sine A cosine B. Now sine of pi over 2 minus A, using the cofunction identity, the second cofunction identity, is cosine of A times sine B. And look, now we've got the formula, the addition formula for sine, because we started with sine of A plus B, and we reduced it down to sine of A cosine B plus cosine of A sine B. So that's where the addition formula for sine comes in. And finally, sine of A minus B, we're going to do the same trick that we did for cosine of A plus B. We'll write this as sine, instead of writing it as a subtraction, we'll think of it as adding a negative. So this is sine of A minus negative, or sorry, A plus negative B. And the point of that is that we can then invoke this sine formula that we just proved. So we've got sine of something plus something. And according to the sine formula that we just proved, it's the sine of the first one times the cosine of the second one, which is negative b, plus the cosine of the first one times the sine of the second one, which is negative b. And now again, we're going to use the odd and even properties. This is sine of A. Cosine of negative b, cosine is an even function, so that's cosine of b, plus cosine of A. Actually, I shouldn't have said plus, because look, we have sine of negative b, and sine of negative x is negative sine x. So this is minus cosine A sine b. But now, we started with sine of A minus b, and we derived sine A cosine b minus cosine A sine b. That's exactly the subtraction formula for sine. So in each one of those identities, we didn't use anything external. We just started with the identity for cosine of A minus b. And then we made some clever substitutions to figure out cosine of A plus b, sine of A plus b, and sine of A minus b. Just making little substitutions into the one formula that we started with to get the formulas for the other three expressions. Remember, it was a lot of work to prove that original formula for cosine of A minus b. But once we have that one, we can sort of milk it over and over again to get the other three formulas.